Recently, after watching a series of science fiction films depicting alien invasions of Earth, I have been deeply perplexed. In these films, Earth's inhabitants engage in intense clashes with extraterrestrials from distant galaxies, whether it's in close combat or using firearms and laser weapons. Although the scenes are intense, they strike me as comical. I can't help but wonder, how could an advanced civilization capable of traversing countless light years to reach Earth find itself locked in such evenly matched struggles with humanity, which is as insignificant as ants? Even more absurdly, there are instances where superheroes swoop in to save the day, akin to a person fighting an ant, but instead of simply crushing it with a foot, they create a tiny, ant-sized suit and limit their strength to that of an ant's, engaging in a ridiculous biting contest with the ant, only to end up being defeated by a stronger ant. Why do directors simplify conflicts into battles of equal footing? Is it a lack of imagination on their part, or are technical limitations preventing them from presenting grander sci-fi scenarios? Or perhaps it's due to narrative necessity. If the aliens possessed overwhelming power, capable of eradicating humanity with a mere glance, the story would lose its traction. Thus, we might as well draw inspiration from the evolution of human weaponry and attempt to envision the cutting-edge armaments that an alien civilization might wield, or even the extraordinary abilities that deities might possess. Such contemplation is not only an exploration of the boundless possibilities of science fiction, but also a leap across the boundaries between reality and imagination. The age of cold weapons can be traced back to the Stone Age. During the Paleolithic period, primitive humans primarily used chipped stone tools as labor implements, such as stone axes and stone knives. Although simple, these tools demonstrated humanity's ability to harness natural resources. By the Neolithic period, with population growth and the organization of hunting activities, wars gradually increased, and stone tools began to be used as weapons. These stone weapons encompassed not only stone axes and knives, but also stone spears, stone daggers, and more, often crafted from locally available materials and honed for use. Simultaneously, people utilized non-metallic materials like wood, bamboo, bone, clam shells, vines, and leather to create weapons like wooden clubs, bamboo arrows, and bone needles. Though rudimentary, these primitive weapons were crucial for tribes to triumph in warfare during that era. Following the Stone Age emerged a brief period of copper and stone coexistence. During this time, stone tools remained prevalent, yet copperware began to infiltrate daily life. Initial copper artifacts were mostly red copper, characterized by low melting and hardness points, yet significantly harder than stone. The earliest red copper weapons emerged in the Fertile Crescent, drastically altering the landscape of warfare. These weapons not only enhanced combat capabilities, but also fueled advancements in metallurgy. As technology progressed, people began to cast alloys, with bronze, a combination of red copper, tin, and sometimes silver, emerging as a harder and more ductile material. The advent of bronze weapons marked a new phase in the Age of Cold Weapons. The Bronze Age represented one of the heydays of cold weaponry development. Around 4,000 years ago, regions in West Asia pioneered the Bronze Age. China also embraced widespread use of bronze weapons during the Xia dynasty, peaking during the Shang dynasty. Bronze weapons were diverse, encompassing daggers, spears, bows and arrows, among others. They were not only sharp and durable, but also aesthetically pleasing, becoming the primary armament of armies. The introduction of bronze weapons significantly bolstered military prowess, spurring the expansion of war scales and transforming warfare tactics. During this period, infantry combat gradually gave way to chariot warfare, with charioteers becoming the backbone of armies. Additionally, new combat formations like tactical arrays emerged, rendering warfare more intricate and intense. The Iron Age ushered in another significant transformation within the Age of Cold Weapons. Over 2,000 years ago, the Hittite region of Anatolia pioneered ironworking technology. China entered the Iron Age later, roughly during the late Warring States period, but swiftly advanced to a world-class level. Iron weapons, far sharper and more resilient than bronze, gradually supplanted their predecessors. Their emergence not only enhanced military prowess, but also fueled the rapid development of cavalry. Heavily armored cavalry emerged as the primary force, expanding the scale and scope of warfare. In the Iron Age, cold weaponry warfare reached unprecedented heights, with tactical arrays and long-range raids becoming prevalent. With the invention and widespread application of gunpowder, the age of cold weapons gradually declined. The advent of firearms fundamentally altered warfare. They increased lethality and enabled victories through remote attacks, transcending face-to-face combat. During the Ming Dynasty, firearms were widely employed in warfare, becoming vital military equipment. Nevertheless, despite their proliferation, cold weapons did not entirely disappear, but continued to be used in specific contexts and regions. To this day, cold weapons retain significant roles in some countries and regions. The evolution of the age of cold weapons is a microcosm of human civilization's progress and the evolution of warfare. From the rudimentary weapons of the Stone Age to the glory of the Bronze Age, the brilliance of the Iron Age, and the transformation brought by the Gunpowder Age, each stage bears testament to humanity's wisdom and courage. Though cold weapons are no longer the primary armaments in modern warfare, their historical significance and cultural value remain irreplaceable. Long, long ago, when our ancestors fought battles with spears and bows and arrows, they could never have envisioned that one day, the battlefield would witness the emergence of wondrous weapons capable of spewing flames and emitting thunderous noises. This marked the birth of thermal weapons, which revolutionized warfare forever. Let us delve into this history, from the initial sparks to the unleashing of devastating power. Our story begins with China's Song Dynasty, over 1,000 years ago. During that era, ingenious Chinese inventors crafted gunpowder and encased it within bamboo tubes, creating the earliest firearm, the bamboo fire lance. Though crude in appearance and frightfully loud, its power should not be underestimated. It heralded the commencement of a new chapter in human warfare, the age of thermal weapons. Over the subsequent centuries, firearms began to take root across the globe. Europeans, too, mastered their craft, progressing from simple handguns to more intricate cannons, thickening the haze of battle. Yet, cold weapons had not yet fully retreated. Knights still rode their steeds, wielding swords in daring charges. Firearms and cold weapons intertwined on the battlefield, in a clash between the ancient and the modern. By the late 18th to mid-19th centuries, firearms had reached new heights. The Industrial Revolution accelerated their production, making them faster, better, and cheaper. Cannons emerged as battlefield giants, capable of bringing down walls and striking fear into enemies' hearts with a single blast. Rifles grew increasingly precise, enabling soldiers to shoot from greater distances. Cold weapons were largely phased out, as thermal weapons rose to prominence, dominating the battlefield. At the turn of the 19th and 20th centuries, the world underwent profound transformations. Giants such as airplanes, tanks, and warships emerged. They soared through the skies, rumbled across the land, and traversed the seas, unleashing artillery barrages and strafing with machine guns. They became mobile war fortresses. Thermal weapons transcended mere guns and cannons, integrating with mechanized platforms to form formidable combat systems. Entering the 20th century, the development of thermal weapons accelerated at an unprecedented pace. The advent of high-tech weapons like missiles, aircraft carriers, and fighter jets escalated the destructive power of war to new heights. A single missile can traverse vast distances, striking targets with pinpoint accuracy. While these weapons are formidable, they also serve as a stark reminder of the horrors and devastation of war. As early as the 19th century, scientists embarked on exploring the mysteries of the atom, unaware of the profound impact it would have on the world. Yet, it was these endeavors that ultimately led to the birth of nuclear weapons, a terrifying instrument that has reshaped human history. The narrative commences in the early 20th century, when scientists uncovered the immense energy latent within atomic nuclei. They embarked on various methods to unlock this treasure trove of energy. Among them was Enrico Fermi, whose experiments revealed that bombarding atomic nuclei with neutrons could produce new radioactive materials. While he did not directly discover nuclear fission, his research laid the groundwork for subsequent fission experiments. In 1938, Otto Hahn and Fritz Strassmann jointly discovered the fission of uranium nuclei. Simply put, when a uranium nucleus is struck by a neutron, it splits into two smaller parts, releasing colossal amounts of energy. This discovery stunned the scientific community and sparked widespread imagination regarding the application of nuclear energy. As research into nuclear fission deepened, scientists began contemplating how to harness this energy for weaponry. In 1939, a group of scientists advised President Roosevelt of the United States to preempt Nazi Germany in developing the atomic bomb. Consequently, the U.S. initiated the renowned Manhattan Project, mobilizing tens of thousands of top scientists and engineers. After 3 years of intense effort, the world's first atomic bomb was successfully built in 1945. In July 1945, the United States successfully tested this atomic bomb in New Mexico, with the massive explosion and mushroom cloud stunning the world. Just a month later, this weapon was unleashed on the battlefield, with 2 atomic bombs dropped on Hiroshima and Nagasaki, Japan. These bombs caused hundreds of thousands of casualties and immense destruction, giving humanity a chilling glimpse of the terrifying power of nuclear weapons. With the U.S. successfully developing the atomic bomb, the Soviet Union was quick to follow suit, developing its own nuclear arsenal. This ignited an intense nuclear arms race between the U.S. and the Soviet Union. During this period, both countries not only produced vast quantities of atomic bombs, but also developed even more powerful hydrogen bombs and other types of nuclear weapons. This race not only cast a dark shadow of nuclear war over the globe, but also accelerated the proliferation and development of nuclear technology. As the number of nuclear weapons grew and their destructive power escalated, nations worldwide began to recognize the peril of nuclear war. Consequently, measures were taken to limit the proliferation of nuclear weapons and reduce their numbers. In 1968, the United States and the Soviet Union signed the Treaty on the Non-Proliferation of Nuclear Weapons, NPT, aimed at preventing the spread of nuclear weapons to other countries. Since then, nations have engaged in numerous negotiations and consultations to restrict the number and use of nuclear weapons. While efforts for nuclear disarmament and non-proliferation persist, modern technological advancements have made the production of nuclear weapons easier. Additionally, countries are developing new types of nuclear weapons to address potential security threats. However, it is imperative to acknowledge that nuclear weapons remain one of the greatest threats facing humanity. They have the capacity to inflict massive military strikes, human devastation, and environmental catastrophes, making them the most lethal and terrifying weapons in modern warfare. First and foremost, let us delve into the enigmatic and formidable realm of antimatter. In 1928, the esteemed British physicist Dirac first predicted the existence of antimatter, proposing that every particle of matter has a corresponding antiparticle, sharing the same mass but opposite in charge. These antiparticles can coalesce into antiatoms, which further constitute antimatter, implying that everything in the universe, ranging from microscopic antiatoms to vast antigalaxies, possesses its antimatter counterpart. When antimatter encounters normal matter, they are mutually attracted and undergo a violent collision, a process known as annihilation. The energy released during this annihilation is considered the most pristine and formidable form of energy in the universe. Scientists' calculations reveal that the destructive power of just 0.5 grams of antimatter is equivalent to the energy unleashed by the atomic bomb that devastated Hiroshima in 1945. Even more astonishing, 1.5 kilograms of antimatter possesses an energy yield that surpasses that of the Tsar Bomba, the most powerful nuclear weapon ever tested by humanity, with the explosive force capable of obliterating any city on Earth and affecting an area extending 35 kilometers around it. To better comprehend the terrifying potency of antimatter, let's compare it with other natural disasters. The destructive power of 10 kilograms of antimatter, do you know how powerful it is? According to scientific estimates, the energy it produces is almost equivalent to the damage caused by the 2004 Indian Ocean earthquake, which was the most severe undersea earthquake in modern human history. Strongly impacted by the intense compression of tectonic plates, the Indian Ocean experienced terrifying tsunamis as high as 30 meters. Numerous coastal countries, including Thailand, suffered devastating blows, with the number of fatalities and missing persons exceeding 300,000. Post-event statistics show that the shockwaves from this earthquake traveled around the Earth a full 3 times. However, this massive destructive force is only comparable to the energy released by 10 kilograms of antimatter. If it were 500 kilograms of antimatter, the energy released would be immense. Are you aware of the eruption of Mount Tambora in Indonesia in 1815? It was one of the most powerful volcanic eruptions in recent centuries, with volcanic ash particles covering an area with a radius of 500 kilometers and having severe impacts on the global climate, including large-scale extinctions of animals and plants. Indeed, this is the terrifying power that 500 kilograms of antimatter possesses. Despite its immense destructive capability, antimatter also holds immense promise as an ideal fuel for aerospace travel. Theoretically, the thrust generated by just 10 grams of antimatter would be sufficient to propel a spacecraft to Mars within a short time frame, significantly shortening the current travel duration. However, the production of antimatter is extremely challenging and costly. As antimatter scarcely exists in nature, its creation necessitates intricate scientific experiments and substantial financial investments. Currently, human technology is unable to mass-produce antimatter, making the search for more economical and efficient production methods a pressing challenge for the scientific community. Antimatter, this enigmatic and formidable entity, both ignites our curiosity about the mysteries of the universe and fuels our concerns about its potential threats. As technological advancements continue, we may gain a deeper understanding of antimatter and discover safe, effective ways to harness its power. Yet, until that day arrives, we must remain vigilant, ensuring that the research and application of antimatter do not result in catastrophic consequences for humanity. Taking it a step further, such a civilization might have already harnessed the power of certain fundamental rules, which serve as the underlying codes and the very fabric of our universe. For instance, the speed of light in a vacuum, denoted as c, is 299,792,458 meters per second, and there are principles like conservation of momentum and conservation of angular momentum. If these basic rules were to change, our universe would undergo profound transformations. However, in this era, advanced civilizations have the capability to utilize and even modify some of these rules. In the science fiction novel, The Three-Body Problem, there exists a substance known as the water drop. This exquisite material, reminiscent of the tears of a Madonna, is composed of strong interaction forces, the most potent of the four fundamental forces in physics, typically confined to the microscopic scale of atomic nuclei, where positively charged protons and neutral neutrons are bound together by this unique force that grows stronger with distance at tiny scales before rapidly diminishing to near zero. Advanced civilizations have altered the laws of physics, extending the reach of strong interaction forces to create this impeccable substance. This material is superbly hard, virtually indestructible, rendering any human-made material as fragile as a sheet of tissue paper before it, and piercing through the earth as effortlessly as a bullet through cheese. The water drop's flight capabilities are equally astonishing. It can execute sharp turns without decelerating, a maneuver that renders human warships incapable of tracking it. This is because the water drop violates the laws of conservation of momentum and conservation of angular momentum in physics, a mode of movement deemed virtually impossible in reality. Its attack method is simple yet devastating. It destroys targets through high-speed collisions. When it strikes an enemy ship at immense velocities, its colossal kinetic energy effortlessly penetrates the ship's armor, converting the ship's internal matter into energy and consuming it. This form of attack is both efficient and lethal, leaving arrogant humanity powerless and as vulnerable as ants before such might. Beyond altering the range of strong interaction forces and conservation of angular momentum, what else can one envision? Yes, indeed, gravity is another ubiquitous example. Humans can generally withstand 3 to 4 g-forces, with no one able to endure more than 10 g-forces, owing to one of the rules of our universe. Humans can generally withstand 3 to 4 g-forces, with no one able to endure more than 10 g-forces, owing to one of the rules of our universe. Advanced civilizations can manipulate this constant in certain regions of space, subjecting individuals to hundreds or even billions of times the normal gravitational acceleration, potentially crushing them into a heap of atoms. Of course, the use of such power may be subject to limitations. Just as your air conditioner blows cool air indoors while emitting hot air outdoors, even advanced civilizations creating such weapons still inhabit our universe and must abide by its rules, including the law of entropy increase. Our planet experiences hot summers and cold winters. While you can adjust indoor temperatures with an air conditioner, you contribute to the overall entropy increase of the universe. Time and space weapons also rest upon the foundation of rule-bending weapon. Consider the case of time weapons. If an advanced civilization were to invade a less advanced one using time weapons, how might they do it? They would manipulate their own speed of light, making it significantly lower, while leaving the speed of light for the less advanced civilization unchanged at 299,792,458 meters per second. What advantages does this offer? Assuming Einstein's general theory of relativity holds true, the closer one gets to the speed of light, the slower time flows. Since the advanced civilization's speed of light is greatly reduced, they can easily approach near light speeds with minimal movement. This means they would observe the less advanced civilization in slow motion, or even as if frozen in time, able to witness you age and perish before them. Conversely, the less advanced civilization, with its unchanged speed of light, would perceive the advanced civilization as moving at the speed of light, while their own projectiles like bullets, rockets, or any other means of propulsion, would pale in comparison. This creates an asymmetrical battlefield where the less advanced civilization stands little chance against the advanced one. Now, let's delve into space weapons. One of the most iconic space weapons in science fiction is the dimensionality strike or two-dimensional foil from Liu Cixin's novel, The Three-Body Problem 3, The Dark Forest. The principle behind the two-dimensional foil revolves around changes in dimensionality and the application of cosmic laws. In the novel, it is depicted as a weapon capable of reducing the dimensionality of space, harnessing certain laws or forces within the universe to compress objects or regions in three-dimensional space into two dimensions. The two-dimensional foil might achieve this by compressing one dimension of three-dimensional space, thereby gradually consuming and dismantling it. This process resembles squashing a three-dimensional cube into a two-dimensional plane, with much of the original three-dimensional space ceasing to exist in its original form. In theoretical physics, particularly branches like string theory, changes in spatial dimensions can be likened to a phase transition, akin to liquid water transforming into vapor. When the two-dimensional foil comes into contact with three-dimensional space, it may trigger a jump in the energy field of the three-dimensional space towards a lower energy state, generating a field known as the tachyonic field, which in turn creates a vacuum bubble. This vacuum bubble continually expands, causing vacuum decay and ultimately engulfing the entire space. During this process, objects and regions within the three-dimensional space gradually become two-dimensional. Some speculate that the two-dimensional foil may neutralize one dimension of three-dimensional space by introducing negative dimensional space. However, this remains a speculative concept rooted in science fiction and has not been scientifically validated. Given such an attack, how might a less advanced civilization defend itself? Are we living in a three-dimensional foil, created by an advanced civilization? You're not thirsty because you recently drank a cup of hot water. But what if you hadn't? What if you hadn't drunk any water for even longer? Would you have perished from dehydration? Your existence stems from your parents' meeting and union before your birth, and your triumph as the one victorious sperm among billions. But had your parents not met for some reason, had they not united, or had the atomic arrangement that formed you been different, would you still exist? The existence of each of us, every single thing, is a culmination of countless coincidences, from the tiniest viruses to the vast expanse of the universe. One of the fundamental rules of our universe, the speed of light at 299,792,458 meters per second, is but one of the incredible coincidences that arose at its birth. A minuscule change in conditions could have altered every one of us, everything, and perhaps even the entire universe. This underscores the immense power of the weapon of cause and effect, and the divine, being the ultimate master of this weapon, not only controls the birth, aging, sickness, and death of every individual at every moment, but also the state of every universe at every instant. The divine, as the supreme sovereign of cause and effect, stands beyond time and space, weaving the most intricate web of destinies with boundless wisdom and compassion. Not only is it the bearer of the weapon of cause and effect, but also its designer, ensuring with infinite patience and precision that every grain of dust, every star, and every pulse of the universe follows a predetermined harmony and order. In the realm of the divine, cause and effect is not merely the law governing all things, but also a bridge of love and redemption. It teaches us that every choice, every effort, no matter how small, invisibly shapes our individual destiny while also being intricately intertwined with the destinies of others, collectively painting a magnificent tapestry of life. Hence, when confronted with life's challenges and perplexities, let us look up at the vast expanse of the starry sky and remind ourselves, within this grand cosmic landscape, we are both participants and witnesses of the law of cause and effect. Let us approach every choice with reverence and every life with compassion, for in the realm of the divine, within cause and effect, we are all connected, collectively authoring the most touching stories of the universe. Lastly, in your opinion, what kind of weapons could aliens that are capable of invading the Earth possess?